synthesis gas and phenol formaldehyde, 2 for the price of 1. Eh? Well, what the heck is formaldehyde? I think that's maybe where we want to begin this little story. Formaldehyde. It's an old-fashioned name, formaldehyde. You might manage to see in there aldehyde. Formaldehyde is an old name for what we would nowadays call methanol. Methanol, the simplest of all the aldehydes. You might see it drawn in various ways. There's a typical aldehyde structure. If this is methanol, there aren't any more carbons, just the one. Or we could maybe draw it like this. It's exactly the same substance, aldehyde. Or we could even draw it, and this looks a little bit bizarre, but we could even draw it something like this. You have to recognise methanol no matter how it's presented. Formaldehyde. It's, nowadays its most common use is as a preservative for dead remains. Anyway, that's by the way. Now, secondly, this formaldehyde is needed to produce a polymer called phenol formaldehyde. So we're going to need large quantities of formaldehyde. This maybe raises the question, how do we make an aldehyde? How could you go about making an aldehyde? Well, here's one possible route. Let's imagine something simple like an alkane. Imagine ethane. Okay, ethane. Now there's an abundance of ethane out there. It's in natural gas. It's a very common raw material. We could take ethane and quite easily turn it into ethene. How would we do that? How could ethane be made into ethene? Well, we can see we've removed a couple of hydrogens. Dehydrogenation, removing hydrogen. But this is often seen as cracking. This step is an example of cracking. Given the right conditions, you can snap off a couple of hydrogens. What will we do now? Well, our aim is to make an aldehyde, so maybe the next step is to make this into an alcohol. There it is. This is ethane, ethene, ethanol. How can we make ethanol? We've done all this chemistry before. This time we're adding water. If we add water to this double bond, we'll end up with ethanol. What do we call adding water? Well, it's an addition reaction. We're adding across the double bond, but maybe we call it hydration. Hydration implies adding water. And in the last step, our aim is to make an aldehyde. Our last step would be to turn ethanol into ethanol. Again, a fairly easy process, one that we should know. How do we turn alcohols into aldehydes? Oxidation would be the case here. There's only one problem, and the problem is the aldehyde we want is methanol. It has only one carbon atom, and therein lies a problem. Because we cannot use this route to make methanol. Why not? Because tracing this back, we need an alkene, and you cannot have an alkene having a carbon-carbon double bond. You can't have that with only one carbon atom. It's a complete contradiction. So it's back to the drawing board. We cannot make methanol by this route. We'll need to find an alternative route, and that's where synthesis gas comes in. Synthesis gas. As its name implies, it's a gas which has been made. It's synthetic, it's artificial, it's been created. Synthesis gas is a mixture of carbon monoxide and hydrogen. So where is it made from? Well, there are two possibilities. Either get some methane, again, cheap raw material, there's an abundance of methane out there, natural gas, and react it with steam. Both of these are raw materials, they're commonplace. This would be called the steam reforming of methane. Let's go over that. This is methane gas, this is steam. And the reforming implies a rearrangement of atoms. If you look at this, the carbon and oxygen join together to form carbon monoxide, and the 4 plus 2, the 6 hydrogens, end up producing 3 times H2. There it is. we can make synthesis gas, sometimes called syngas, by this steam reforming process. There's an alternative route, and that is one which still involves steam, but this time an alternative raw material, that is coal. Again, an abundant raw material. Given the right conditions, we can persuade coal and steam to react. The only difference is that in this case, we'll get C and O, CO, and we'll only get one lot of hydrogen. It doesn't matter. The ratio doesn't matter. It's simply a mixture of carbon monoxide and hydrogen counts as synthesis gas. Now, we want this synthesis gas to make methanol. How do we do that? Earlier on I had a 1 to 3 ratio. Just now I had a 1 to 1 ratio. How about a 1 to 2 ratio? Now it's possible to take this mixture of carbon monoxide and hydrogen and persuade it to produce this substance. There. What do we have there? We've got methanol. It adds up 1 carbon, 1 oxygen, 4 hydrogens. Then it's possible to turn methanol into methanal. This is a primary alcohol. We want an aldehyde. This works. This will be oxidation. We take our alcohol. Yes, we can turn this alcohol, this 1 carbon alcohol, into methanol. So, what have we done? We've found a route to methanal, or as it used to be called, formaldehyde. Formaldehyde. But why do we want this substance? Let's go back over this. We want to make a polymer called phenol formaldehyde. It follows we need formaldehyde, we need methanol. So there it is. Formaldehyde is methanol. It can be drawn in various ways. How do we make an aldehyde? Well, most aldehydes can be made by this route, by starting with an alkane, by cracking an alkane to make an alkene, then adding water, hydration, to form an alcohol, and then oxidizing the alcohol to make the aldehyde. That's great, except that our aldehyde has only 1 carbon atom. So we'll need to find an alternative route, and the alternative route was via synthesis gas. You are guaranteed 100% to get a question about synthesis gas in the exam. You need to know that synthesis gas is a mixture of carbon monoxide and hydrogen made by the steam reforming of methane or the steam reforming of coal. Anyway, what use is synthesis gas? It can be turned into methanol and make a 1 carbon alcohol into methanol. The last piece in this puzzle is to make the polymer. So here we are, that was number 3. Number 4 is looking at this phenol formaldehyde. Phenol formaldehyde is a polymer. It's a condensation polymer. So let's have a look at this. Now, phenol, there's a clue in the name. Phenol is an alcohol. It has an OH group, alcohol. And the phenol implies benzene. What you have to remember is that on this benzene ring, there are hydrogens. We don't normally bother to draw them, but they are there. Let's have another one of these benzene ring structures. What we're trying to do here is to assemble these to form a polymer. This is a very important polymer, a very tough polymer. Where does a methanol come in? Here is literally where it comes in. There's our little methanol molecule. You see the potential for condensation? We can get these 3 atoms, the 2 H's and an O, to join together. If I was to do that, take out H, H and O, what would happen now? One of these bonds would join there, and one of these bonds would join there. We're going to join it together. Suppose we had another methanol molecule down here. They would have exactly the same. Remove H2O, and these bonds form a link. There. If this would happen many, many times over, we would have a polymer, and it would be a condensation polymer because it involved the loss of water. This phenol formaldehyde is a thermosetting polymer. It's extremely tough material, got a high melting point. In fact, it won't melt at all if it's thermosetting. It's more likely to catch fire than anything. But there it is. It's a slightly obscure condensation polymer, but that's it expected.